Hi and welcome. In the previous week's video, we have seen the same question but the easy version of the question. I told you that in the next week, that is the current week, we will solve the hard version of the same problem. Correct? We have solved the easy version. In this video, we are going to solve the hard version of character swap which was asked in Codeforces contest number 599 division 2. Fine, we are going to solve this question. We are going to discuss. Like all the videos, this video will also be divided into three parts. The first one, problem understanding. The second one, we are going to see the logic approach, the algorithm, and the third one, we are going to see the implementation. Okay, so the link of the question is provided in the description box. So go to that link, read the question, try to understand the question and the test cases on your own. Then come back and see the whole video. Fine. Now I am going to explain character swap hard version. Okay. So let's begin with problem understanding. So let's read the question out. Ujjan has two strings, distinct strings, S and T. So we have two strings. Write the important points. We have two strings, S and T, and both are distinct. Okay. Next point. Of length n. They both are of length n. N equals to length. Fine. He wants to make them equal. So the task is to make S equal to T, to make them equal. Fine. Since Ujjan is lazy, he will perform the following operations at most 2n times. So there will be an operation that will be performed at most 2n times, not more than 2n times. Okay, at most 2n times, where n is the length of the strings. Okay, what is the operation? He takes two positions, I and j. How many positions? Two positions, I and j, and swap Si and Tj. Swap Si and Tj. Fine. So what is the operation? He takes two positions I and j and swap Si and Tj. Okay, this operation can be performed at most 2n times. And after swapping the characters of the strings S and T, we need to make those strings equal. Okay. Now the next point is Ujjan's goal is to make the string S and T equal. He does not need to minimize the number of performed operations. So there is no need to minimize the number of operations. Okay, we can choose any number of operations any number of times. Fine. Now let's begin with the input format. So first we will have k, that is the number of test cases. Then we will have the values of S and T and the value of n. Fine. We have to print yes if Ujjan can make the two strings equal and no if he cannot. And if the answer is yes, then what we need to do? If the answer is yes, then we need to output an m, that is the number of swaps that are taken to make the both strings equal, and in the next n steps we need to write the positions I and j that are swapped with each other. The positions I and j, we need to write it down. Okay, for example, in this test case, the first one, can they be made equal? Yes, we have also seen in the last video, they can be made equal. Okay, and in how many swaps can we make them equal? In a single swap we can make them equal. And what are the position of those swap? So the fourth character in this T string is swapped with the first character of the S string. Okay, so first character of the S string is swapped with fourth character of the T string, therefore 1 4 is written here. Now there can be many possible answers. We do not need to minimize the number of operations. Okay, we just need to print how many operations we performed, how many swaps we performed, and what was those swaps with yes and no. Okay, so this is the problem. These are the important points in the problem. Next we will see the constraints test cases when we are building our logic. So this part was problem understanding and nothing else, just what is written in the problem. I have explained only that much. Now let's begin with the logic approach, how we will build the algorithm, the logic to solve this problem. Fine, let's begin with that. Let's take some examples. Okay, so for S equals to A, B, C, for example, this is my string, and T equals to B, C, A. Now what do you think how we will perform the operations? We can perform at most 2n number of operations. So just think, given that test case, how we will swap and what we will swap. Now just think, given this test case, what will be the number of swaps to make them equal? What are the conditions that should be satisfied so that we can say yes, these strings can be made equal at the end by swapping? We can check for some conditions in the beginning only to know whether these strings can be made equal or not. So if they cannot be made equal at all, then we will not perform any swap operations. And if they can be made equal, then we will perform some swap operations. So just think what can be those conditions. Okay, think how many swaps do we need and what will be those swaps for this particular test case. You can take any number of test cases. For example, we can take A triple B A. Also we can take A B A. Can these two be made equal to each other? So given these two strings, given these two examples, just think how can we move forward from this point. Okay, just think on your own first and then see the video. Fine, pause the video right now and think on your own first. Let's see for the first test case, which is nothing but S is ABC and T is BCA. So first of all, the first point, can they be made equal? Can they be made equal? Can I perform subswapping such that S equal to T? Is it possible? So let's see. So we have an A here, we have a B here. So we need A with A. So is there any A present? Yes, A is present. A is present. So can we swap this A and B? Just think about it. Can we swap this A and B? Is it allowed to swap this A and B? So if you think yes, then you are wrong, because it is not allowed to swap A and B. We can only swap by choosing I and J positions. So for example, this is I and this is J. Choosing I and J positions, we can only swap Si and Tj. We can only swap Si and Tj. That means one character from the S string and the second character from the T string. We can only swap Si and Tj. We cannot swap Ti and Tj. Okay, you cannot swap the characters of the same string. You cannot swap the characters of the same string. This is wrong. Okay, this is also wrong. We cannot swap the characters of the same string. We have to swap the characters of the different string. Fine. So you cannot swap like this. You cannot swap like this. This is the first important point that needs to be taken care of. Okay, so the next point. So yes, we do have an A. So that means while performing some operations, this can be done. We do have an A, so A and A can be made equal, but it cannot be made equal just by performing swapping on the same string. What we can do? So if you want to make A here and you cannot go directly, then think, can you go indirectly? This is possible. We can swap Si and Tj. Okay, we can swap Ti and Sj. This is possible. We can swap the characters of different string S and T. This is possible. So think, can we go in some other manner? Can we perform these operations in some other manner? Think about that point. The answer is yes, we can perform in an indirect way. What is that indirect way? So it is very simple. So just think, what is that indirect way? We can swap two characters of Si and Tj. So this will become ABA and BCC, correct? And now we can perform this operation of swapping between Si and Tj, that is S and T strings can be swapped now. S and T characters, A and B characters in the string S and T can be swapped now. Now these can be swapped. What will be the answer? It will be ABB and ACC. This will be the answer. Okay, so is it possible to swap like this? Yes, it is possible to swap like this. So the first swap that was made was with S and T, that is two different string, and the second swap that is made is also of S and T, that is two different string, which is allowed, and we do not have any restriction on the number of operations. We do not have any restriction on the number of time we have to perform the operation. So using two swaps, we can perform the operation indirectly. Okay, we cannot swap between the same string, but using two swap, we can perform the operation indirectly. That is the first important point. Now let's see the next one. So now it is S and it is T. Okay, these two are equal. Is these two equal? No, they are not equal. Okay, B and C are not equal. So any B, because we need to make it B or we need to make it C. Okay, so either we need to make this as B or this as C to make them equal. Am I correct? So is there any B present here or here? Why I'm checking in both the strings? Because we can swap in the different string. We can swap any character from any position to another string anywhere. Okay, we can swap any character from any position to another string anywhere, correct? So we have to check in both the cases. We have to check in both the strings. So is B present? Yes, B is present here. Can we swap these characters? Can we swap these characters between S and T? Yes, this is allowed. We can swap the characters between S and T. So when this is swapped, this will become ABC and this will also become ABC. This is S and this is T. So here these are same and these are same. Now S equal to T. Okay, so how many swaps we perform? Just think about it. Do not answer it directly. Think about it. How many swaps actually we performed? We did not perform 2 swaps. We performed actually 3 swaps. In total, how many swaps? 3 swaps we performed. The first one was this, the second one was this, and the third one was this. So in 3 swaps, we get our answer. In 3 swaps, we get our answer. And what are those swaps? From the first and the third, that is, this is the third and third, correct? The third character. So from third and third character we swapped. Then we swapped the third character and the first character. And then we swapped the third character with the second character. So using these swaps and total 3 number of swaps, we made S equal to T. We made S equal to T. So we have seen so many cases here. We have seen so many cases. The first one is you cannot swap between the same strings. You have to swap between the different strings. Therefore, we need to have 2 swaps. We need to have 2 swaps in this case. Here it is just a single swap. Here it is just a single swap. Fine. So let's form a logic around this. Let's begin with that point only. So let's see the first point. The first point is if we have a mismatch. If we have a mismatch, let's try to form a logic. If we have a mismatch, okay, mismatch, then either you will find the same character in the same string, that is if I have Si is not equal to Tj, okay, either I will find the same character that is present in Si in some different index of the same Sj, of the same string, or I will find the same character Si in my T string. Okay, now if I find the character in the same string, if I find the same character in the same string, that means this case, the second case that we have seen, okay, we have A, B, B and A, C, C. We need to find this character. Am I correct? We need to find this character. So is this character present in the S string or T string? This character is present in the S string, that is nothing but the same string, that is nothing but the same string, correct? So this is the case 1, that is A case. The first that we see was the second case right here, correct? That here we need to have an indirect swapping. Here we need to have indirect swapping because the character that we found out in S was at present at the third place of T of different string, correct? So therefore here this is case B. We have case A and case B. Now in case A, you can directly swap. You can directly swap with S and T. In case B, there are 2 swaps. There are 2 swaps. Till now we have seen this much part. Till now we have seen this much part. Okay. Let's move forward. Let's take more test cases. Before writing any code, we need to take more test cases. We need to check whether our condition is correct, our logic is correct. Are we missing some test corner cases or not? We need to check this. Can we directly apply this algorithm or the constraint will not allow it? Okay. Will the constraint allow it? Are there any corner cases we are missing, or are there any no corner cases we are not missing? So we have to be some percentage sure. We cannot be 100%. Some percent sure that this is correct. Our logic is correct. Okay. So let's see that by taking some more test cases. We have already seen one more, that is this one. So let's begin with this only. So here S equals to A, B, 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 A, and T is A, B, B, B. Or it is different? Okay, one second. A, B, triple A. Fine. So can they be made equal? So let's see. This is done. Fine. This is same. This is not same. So find B. Find B somewhere in the both strings. Where it is present? It is present in the same string. So that means it is nothing but case A. Case A, that is direct swapping. Direct swapping between S and T. Okay. So swap this and you will get A, B, B, A, A. Okay. And here A, B, B, A, A. fine, you will get this after swapping. That means you swap these parts. Okay, now are they equal? Yes, they are equal, so we will simply stop. There is no other mismatch. So using just case A, we did this finally. Okay, so this was case. There is no corner case in this here also. Let's see some more. So S equals to, for example, A B A, and T equals to A B B. Can they be made equal? So this is something we have not seen before. Now here I cannot have two A's here or two B's here, can I? I cannot make this equal. This is equal, but I do not have an extra A or extra B to make them equal, correct? These two are same, but here I cannot do. Even if I swap, there is nothing I can do here. At this position, even if I swap, there is nothing I can do. There will be a mismatch definitely. Okay, so this is a case we need to handle. We have not handled this case till now. Okay, we haven't handled this case, so we have to handle such cases. So how we will handle such case? That there is certainly a mismatch. So first thing is, we can handle it directly. So if here, after performing all the operations, if there is still a mismatch left at the end, that means print no directly. Print no. After performing all the operations, if there is a mismatch left, then print no. This is one of the methods to handle such a case. Or we can form an observation. We can see an observation in this. Okay, let's see what that observation is. So if S is A, B, C, D, and here T is something else, E, F, A, B. Okay, so what we can do now? We can make A, B and AB as same by some operation. By some operation, I do not know the operations. I haven't swapped it, but by some operations we can make them same definitely. Okay, and the operations will make these two as different also. So by performing some operation, we can make AB and AB equal, and I think these will be swapped out. But we cannot make them equal now because there is only one of them left. Okay, every character is just occurring one time, so therefore we cannot do anything. A character needs to occur two number of times at least to make them swap, to make them equal. For example, here A and A are occurring two times and B and B are occurring two times. So there has to be at least two same characters. Each character has to occur at least two times so that we can swap and make them equal. So we can swap and make the S and T at that point, at that index, same. Okay, so at least two times they should occur, at least. So that means if they are occurring for three times, can we do it? As you can see here, this time A and B were occurring for three times. 1, 2 and 3, and 1, 2 and 3. But we cannot make them equal. So even for one time we cannot make equal. For 3 we cannot make equal. For 2 we can. And we can see just right here that when A and B were occurring 4 number of times, here A was occurring 4 number of times, and here A was occurring how many? 3 and 3, 6 number of times, and B was occurring 4 number of times. Then also we can make them equal. Okay, so that means I think there is an observation. What is the observation here? Odd and even, correct? So if my characters are occurring even number of times, each character, I am talking about each and every character, a character has to occur even number of times, so that in both the strings S and T, I can make the position of that character same. It has to occur even number of time. A, B, B, A, even number of time. Combined in both the strings is also fine. Okay, because we have to swap between different strings. So now A is occurring 4 number of times. So we can make, and B is also occurring 4 number of times. So we can make these two strings actually equal. Okay, because each and every character is occurring even number of times. Okay, now if the character is not occurring for even number of times, each and every character, we need to make sure that each and every character is occurring for even number of time. Okay, only and only then we can actually make them equal, else we cannot make them equal. Okay, so in this case A is occurring 2 number of times, and here also 2, so 4, and here, so we can make them equal. Now in this case A, B, C, A, and here we have T. Okay, so here it is A, B, B, C. So C is occurring 2 number of times, B is 3 and A is 3. A 3, B 3 and C 2. So you can make some A's, some B's and some C's equal, but the whole string will not become equal. The reason being, okay, there will be an A and there will be an B that are mismatched. That will be a mismatch between one A and one B definitely. Okay, so how many number you try, this will not become equal because A and B are not occurring even number of times. Okay, we have two strings S and T. Okay, one character every time will go into one string, correct? So to make that position equal, we actually need two characters. We need two characters. Okay, so same character should occur at least 2 number of times to make them equal, to make that position same. To make that position same, each character should occur at least 2 number of times. Okay, and it has to occur even number of times for the whole string. Fine. So let's now begin this part now. Let's now begin with this. Let's now write down the same thing. So first point, if character count of each character, okay, character count of each character is not even, then directly we can say no. Okay, even if one character we found out such that it is not occurring even number of times, we can directly say no as the answer. Okay, else we need to apply the above logic. Okay, we need to find the mismatch. Once you find the mismatch, there will be two cases. Okay, you find the same character in the same string. If you find the character in the same string, then direct we can swap. There will be direct swap. If you cannot find the character in the same string, that is in different string we find the character. In different string we find the character. Okay, so in that case, if you find in different string, so in that case there will be indirect swapping. Okay, how many number of times you swap, we need to store that part. Okay, because it is asked in the question that how many times you swap, we need to print it. And what are the swap positions, we need to store them also. Fine, we need to store them also. That will be an implementation part, we will see that later. But now let's see what we have just seen till now. So first is character count, then if else condition, and then the matching. So what will be the complexities of this? We have handled the case when there will be odd number and even number of characters. If else will handle it now, the character count will handle it. Okay, and if we can form a string, we can make the strings equal, then in that case, okay, either we have to do direct swapping or we have to do indirect swapping. That part also we have seen. Fine, so let's now see, given the constraints, is this algorithm valid? Will it be accepted in 1 second or not? Or we have to modify it and we have to optimize it, the same algorithm or a different algorithm, to make so that it can be accepted in the given amount of time with the given constraints. We have to see that part now. So let's see the given amount of time and the constraints, and then just calculate the complexity of this, okay, before implementing. Fine. So if we found out that this is not valid for the given constraints and time, we will think of something else. Fine, so let's begin with that part now. So time limit is 1 second. Fine, we have 1000 test cases. Okay, and the length of the string is less than equal to 50 from 2. Okay, so let's now see whether this algorithm will work for these test cases or not. Okay, so first is character count. That is nothing but we can directly create a frequency array. Okay, so that loop will run 26 number of times. Fine, for the n length string. So n length string is nothing but 50. Length is 50, that is nothing but a constant amount of time. Okay, then to check if else maximum, it will run 26, that is also a constant amount of time. Fine, so this is nothing but till now constant. Second, if yes, then we will go to the else case. Now in else case, if we find a mismatch, that is a loop is running here for how many, 50 number of times, that is the length of the string in the worst case. And if we found a mismatch, then a loop will run that is checking for the matching part, correct? That is nothing but, now for example, if we have A, B, that is 3 and 2, 5, and here also we have to do it. That is nothing but A, B, A. So 1 2 3 4 5 6 and 1 2 3 4. Now here we have a mismatch here, so you need to find this A in these two strings, correct? So that is nothing but inside a loop we will have another loop. We will have another loop that in worst case will run 49 number of times. In worst case it will run 49 number of times. Constant. Okay, so in worst case it is 50, in worst case it is 50, and next there is a simple swappings, if and else and swapping, that is nothing but a constant amount of time. So here we have just 50, the length of the string is just 50, correct? So this is nothing but a loop for 50 number of times to create a frequency array, and a loop for 26 number of times for the if else condition, whether it is possible or not, correct? Then a loop for checking the mismatch, and another loop for this checking whether the element is present or not afterwards. Fine. So even if we calculate it out, it is nothing but simple 50 into 50 number of times. The 49 is same as 50, so it will be 2500 number of times. So for a single test case, it is nothing but 2500 number of times in the worst case. In the worst case, correct? And it will not be for 2500 exactly. It is just nothing but asymptotic. Okay, because the first time the loop will run 49 number of times, then 48, then 47, and so on. Okay, so next we have 1000 test cases such, and it is nothing but, let's suppose 2500 only, so it will be nothing but 25 1 0 1, simple. So this is nothing but order of n only, that is nothing but in 1 second. In 1 second we can do this much step. It is done. In 1 second we can perform these many operations, so our algorithm will definitely work. In 1 second we can perform these many operations, therefore the algorithm will definitely work. Okay, it is direct. I think you know the algorithm now. Okay, you can implement it if you try on your own without seeing the code. I am going to show you the code now, but without seeing the code I think you can implement it. Okay, now this was the logical part, the algorithm part, and the constraint. Now let's begin with the implementation part. Now in the implementation part, what do we need? We need a frequency array. Okay, next what do we need? Obviously before frequency array you need a character array of s and t, or the string, whatever you like. There are many possible ways to implement this. Okay, I'm just showing you one of the way. In this way I haven't used any vector, nor I have used any vector pair in C++. Okay, I haven't even used string builder. If you're Java, if you're coding in Java, I haven't used string builders. Okay, so this is common for C, C++, and Java. You can implement it in any language, the implementation that I'm going to show you. Okay, so let's suppose this is the first point. We need S character array and T character array. In the second point, a frequency array will be created. Now that if else condition for the frequency array. Okay, if we go into the else condition, then a for loop for the matching part, mismatch part, and a for loop for swapping part. Okay, now when we swap we need some variables, so to store how many times the swapping is done, and you can use a 2D array, a simple 2D array. Okay, in that array we can store the positions of the swaps. Okay, if 3 is swapped with worst position, in the first position is swapped with second position. So to store these values I am using a 2D array. You can use a string for this purpose also, you can use a pair for this purpose also, but just for simplicity we will be using a simple 2D array. Okay, so this was the implementation part. I am going to show you the code in C++, but the same, almost the same code with the syntax changes can be used in C and can be used in Java. Okay, no particular language part is used here, that is vectors for C++ is not used, string builder for Java, no such things are used. Okay, the implementation will be the same for all the 3 languages. Fine, with the syntax changes. Okay, let's see now the code. So this is the code. So first is taking input of our test case, then taking input of our size, of the array size. Next is just declaring our S array and T array. Okay, the character arrays. So this is the input of the character arrays. Fine. Then a frequency array, and the frequency array is initialized to 0 in the beginning for storing the number of times a character appear. Now this loop is for our frequency array, that each time a character is appearing, for that index we will increment the frequency. Okay, next this is a flag variable. It is used even if one character is occurring odd number of times, we will make flag 1 and we will break. Even if one character is not even, then we will break, we will make flag equal to 1, and we can use break statement here. Okay, we can also use break statement here. So just break and print no, we are done. Okay, else if the character is not appearing even number of times, then no. If the characters are appearing, each and every character is appearing even number of times, then go to the else part. Okay, now here it is the answer array, okay, to store the swap positions, and this is the times, that how many times we are swapping. Before that we printed yes, that yes it is possible. Okay, now this outer loop, that is for the mismatch checking. So if there is a mismatch, that is SRI is S array I is not equal to T array of I, that means there is a mismatch. We'll go to our inner loop. Now inner loop is for swapping purpose, so this is for swapping. So if you find the character in the same array, this is for the same array part, you find the character for the same array. Okay, so this is nothing but same array case. Okay, same array case. So just a simple direct swap, we swap SR and TJ, okay, SJ and TI, we swap them. Okay, we store the required answer into our answer array. Okay, the index positions. Why +1? Because in the question it is not 0 1 2 3, it is 1 2 3. Okay, the second character is the second index, not the first index. Okay, it is not 0 base indexing, it is the first base indexing. Therefore j +1 and I +1. And to keep the count of the print of the swaps, okay, we have times ++, we are incrementing the time, and we are breaking. For the inner loop, we will go to the outer loop, we will again check for the mismatch, and the same process repeats. If we are finding in the different array, finding the character in different array, so this is for the different array case. Okay, we have two swaps. The first swap is between the different SRJ and TJ, and the second swap is for SJ and TI. Okay, I have explained this part. Fine, we will swap indirectly, we are swapping indirectly. Okay, and for each and every swap we will store the answer and we will increment the count. For each and every swap we will store the answer and we will increment the count. We will break the inner loop, then we will go to the outer loop. Again we will check for a mismatch. For each and every character we can only do it 2n number of times. Okay, 2 times. For each and every character we can only do this at most 2 times, therefore n characters, so 2n number of times. Therefore the size you can see is also 2n. Okay, so therefore at most 2n number of times we will perform the operation, and in the finally we will print the answer. So this is the code. Okay, you can just see the code at once like this. So this is the first part of the code. Okay, this is the first part of the code. Here you can pause the video and just check this out. Comments are given. This is the second part of the code. Okay, this is the second part of the code. Fine, and this is the third part of the code. Okay, so this is the whole code for this particular question. Fine, I have explained you the time complexities. I have explained you how we will directly check the time complexity before writing the code. Okay, why there is only 2n number of swaps, I have explained that point. Okay, and all the cases we have handled by taking many test cases. Okay, you can take as many test cases as you like to test the code. Fine, we have used frequency array in this question, we have used swap in this question. Okay, there is a way, there is many ways to solve this question. Actually, to implement this, you do not use frequency array, that is also fine. You can use a flag variable here. If there is a mismatch, even after everything, at the end you can check if there is a mismatch even after everything. At that point you can print no. Okay, this was easier. I thought this was an easier way, that just check the frequencies of even and odd. Fine, but you have to make this observation to implement this way. Fine, so this was the frequency array part, and then no, yes, and directly the swapping part. Swapping part is very simple. Okay, you can create another swap function for these 3 lines. Okay, you can create another swap function. It will reduce the size of the code. Fine. So this was hard version for the character swap problem that we have discussed in the previous video, and in this video we have discussed the hard version. Fine, thank you.